Good morning, students. I am Sheikh Shamshad, working as Maths CRT in KGBV Nadendla, Guntur district. Good morning, students. I am Sheikh Shamshad, working as Maths CRT in KGBV Nadendla. I want to ask you some questions now. Okay? Are you ready to listen? Are you ready to listen? Okay. Do you know? Can you tell the distance from your home to school? Your home to school? Somebody of them, of course you are in local. Can you say it is nearly 1 kilometer or half of the kilometer, like this? Okay. Can you tell what is the distance between Guntur to Vijayawada? Guntur to Vijayawada? Can you tell? Anybody can tell what is the distance between Guntur to Vijayawada? Oh, somebody can guess and tell it is nearly 40 kilometers. Of course, it is absolutely 37 kilometers by roadway. It is 37 kilometers by roadway. Okay. For example, somebody asks you what is the distance from sun to earth. Somebody asks you what is the distance between distance from sun to earth. Sun to earth. Can you tell? Can you tell what is the distance from sun to earth? Okay, nobody can guess. Nobody can guess. Okay, the distance from sun to earth is 1496 million 96 million meters. 96 million meters. 1496 million meters. Okay. Somebody asks you what is the distance from the sun to the earth. Somebody asks you what is the distance from the sun to the earth. Can you guess? Can you tell what is the distance from the sun to the earth? From the sun to the earth, it is 1496 million meter. 1496 million meter. Million meter. Here we also know some large numbers. Here we also know some very large numbers. The estimated diameter of the sun is 140 crore meters. 140 crore meters. Okay. Next, the estimated age of universe. The estimated age of universe is 12 billion years. Is 12 billion years. Okay. Here 12 follow 9 zeros. Here 12 follow 9 zeros. Oh, it is also a large number. Or not? Is it a large number or not? Okay, it is a very large number. Okay. The water on the earth. The water on the earth. Approximately how many cubic kilometers it has? How many cubic kilometers it has? How do you read this number? How do you read this number? Ones, tens, 100, 1000, 10,000, 100,000, thousands. This number is an international system. This number is international system. Okay. This is millions. After millions. After billions. After millions, billions. Okay. Now this number is read as 1,353,000,000 cubic kilometers of water on the earth. Water on the earth. This is also a very large number. Okay. Can you read this number? The mass of the sun. The mass of the sun is this number. The mass of the sun is this one. Can you read this number? Can you read this number? It is looking very large. It is looking very large. Oh, we learned up to trillions. We learned up to trillions. You know about very well up to trillions in international system. Okay, units, thousands, millions, billions, trillions. We know up to this one. Okay, we don't know after places. What are the after places in international system? Yeah, international system. So we feel difficult. We feel difficult to read this type of very large numbers. Do you feel easy? Do you feel easy to read this type of numbers? I think you feel difficult. I think you feel difficult. How do you convert them into shortened form? How do you convert them into shortened form? Can you know how to write these numbers in shortened form? Okay. Here, this is 1496 million meter. This is also write as into. This follows how many zeros? 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay, so we can write this as 10 power 8. 1496 into 10 power 8. This is very easy to learn, easy to tell, easy to write. Easy to write and easy to understand. Okay, can you write this number in shortened form? Oh, why not? Here, 14 follows. 14 follows 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. 14 follows here, 8 zeros. So, you can also write 14 into 10 power 8. 14 into 10 power 8. Okay, here 12 billion years. The age of universe is 12 billion years. Can you write this in shortened form? Yes, that is 12 into, here 12 follow 9 zeros. 12 follow 9 zeros. So, this is write as 12 into 10 power 9. 12 into 10 power 9. Okay, next the water on the earth approximately 1 billion 353 million 353 million cubic kilometers. Cubic kilometers. This number also shortened. 1353 into, here this number follows 6 zeros. So it is right as 1353 into 10 power 6 cubic kilometer. Cubic kilometer. Okay. Now, how can write this number in shortened form? Very large number. How can you write this number in shortened form? Like this: 19891. This follows how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 zeros. Here 26 zeros has this number. So this is right as 19,891 into 10 power 26. 10 power 26. These numbers are in the form of, in which form? These numbers are in the form of exponential form. These are in the form of exponential form. You already learned in 8th class. Recall? These are in the form of exponential form. This exponential form makes us easy to read the given numbers. Read the given numbers easily and write the given numbers easily and understand the given numbers easily. Okay. In this 10 power 26, 10 called as base. 10 called as base. And the 26 is called exponent. 26 is called exponent. This is read as, how do we read this? 10 raise it to the power of 26. 10 raise it to the power of 26. Okay? This is in the exponential form. This is in the exponential form. 10 power in 10 power 26. 10 is called base and 26 is called exponent. 26 is called exponent. What is exponent? What is an exponent? What is exponent? In factors, for example, I will take a small number. In 3 power 6, 3 raise it to the power of 6 or 3 power 6 in shortly. 3 power 6 write as 3 into 3 into 3 into 3 into 3. That means 3 multiplies itself 6 times. 3 multiplies itself 6 times. Okay, which number multiplies itself is write as base. How many times the number multiplied? Here this number multiplied 6 times. That number of times write as exponent. That number of times write as exponent. For example, 2 into 2 into 2 into 2. This is write as 2 power 4. 2 raise it to the power of 4. 2 raise it to the power of 4. That means 2 multiplied itself 4 times. 2 multiplied itself 4 times. The base denotes, what is base here? The base denotes which number multiplied itself is write as base. How many times the base multiplied itself write as exponent. Okay. So we learn about exponent and powers. Today we are going to learn about exponent and powers, which is 4th chapter in 8th class. Which is 4th chapter in 8th class. Exponents and powers. Exponents and powers. Okay. You already learned about exponents and powers in 7th class also. We learn some more concepts in this class. Okay. In this chapter, we are going to learn 4 concepts. What are the concepts are? First, powers with negative exponents. Powers with negative exponents. The second one is loss of exponents. Loss of exponents. And the third one is application of exponent to express in standard form. Application of exponents to express in standard form. To express them in standard form. The fourth concept is comparing very large and very small numbers. Very large and very small numbers. Now, going to learn the first concept. 4.1. Powers with negative exponent. Powers with negative exponents. In this first concept, you already see some numbers, very large numbers. The distance from the sun to the earth, the age of universe. These are very large numbers. Very large numbers. There are very small numbers also. What are the small numbers? Very small numbers. For example, thickness of hair. Thickness of our hair. That is 0.000005 meters. 0.000005 meters. Okay, that is the thickness of our hair. Okay, thickness of microfilm. Thickness of microfilm, that is equal to 0.000015 meter. These are very small numbers. These are very small numbers. Okay, how to express these small numbers? By using exponential in standard form. We are learning in the third concept. Okay. Now, how do we use negative exponents? Powers with negative exponents. Powers with negative exponents. For example, you observe a pattern. You observe a pattern. Okay. 10 power 3. It is write as 10 into 10 into 10. That is equal to 1000. That is equal to 1000. 10 power 2. 10 power 2 write as 10 into 10. It is equal to 1000. It is equal to 100. Sorry, it is equal to 100. 10 square is equal 10 into 10 equal to 100. Okay. 10 power 1. 10 power 1. That is equal to 10. That is equal to 10. What do you observe in this pattern? What do you observe in this pattern? Observe the exponents. Here the exponent is 3. In 10 power 3, the exponent is 3. Here the exponent is 2. Here the exponent is 1. That means the exponent is decreases to 1. The exponent is decreases to 1. Okay, from the before exponent. Okay, then the value becomes 10 times decreases. The value becomes 10 times decreases. 10 times of the previous value. 10 times of the previous value. The value becomes here 10 cube is equal to 1000. After 10 square is equal to 100. It is 1/10 of the previous number. 1/10 of the previous number. What is the previous number here? 1000. 1/10 of 1000. That is equal to 100. Here also 10 power 1 is equal to 10. 10 power 1 is equal to 10. 10 means it is also write as 100 by 10. The previous value is 100. The 1/10 of 100 is equal to 10. Okay. When you decreases the power 1, the value becomes 1/10 of the previous value. The value becomes 1/10 of the previous value. Then can you guess what is the value of 10 power 0? What is the value of 10 power 0? Just to learn. This value becomes 1/10 of before value. 1/10 of before value. What is the before value here? 10. So 1/10 of before value. Before value 10. Then 1/10 of 10. That is equal to 1. That means 10 power 0 is equal to 1. 10 power 0 is equal to 1. If you continue this process, then what is the next power we get? That is 10 power minus 1. We decreases 1 1. The power decreases to 1 1. Here 0. So now the next power we get 10 power minus 1. 10 power minus 1. Can you guess what is the value of 10 power minus 1? Okay, 1/10 of before value. 1/10 of before value. Okay, what is before value? 1 here. So 1/10 of previous value. 1/10 of previous value. So we get 10 power minus 1 is equal to 1 by 10. 10 power minus 1 is equal to 1 by 10. We get. Now, can you guess? Can you tell what is the value of 10 power minus 2? It is also same process. This value becomes 1/10 of previous value. 1/10 of previous value. 1/10 of previous value. Here previous value is 1 by 10. Previous value is 1 by 10. 1 by 10 of previous value. So it becomes 1 by 10 square. 1 by 10 square. Okay. Now again observe one time this. 10 power minus 1 equal to 1 by 10. This is also write as 10 power 1. 10 power 1. Then 10 power minus 2 equal to 1 by 10 square. 1 by 10 square. Now, can you guess what is the value becomes? 10 by 10 power minus 3. 10 power minus 3? Can you guess? Okay. That is equal to 1/10 of previous one. 1/10 of previous value. That is equal to 10 power 1 by 10 power 3. 1 by 10 power 3. Okay. Now, in the same manner, can you write what is the value of 10 power minus n? 10 power minus n. What is the value of 10 power minus n? Then, the value of 10 power minus n equal to 1 by 10 power n. 1 by 10 power n. Okay. In the same manner, we can write any negative power number. Negative power number. We convert that number, okay, a positive power number. Positive power number. After observe these patterns, we could say generally for any non-zero integer a power minus m is equal 1 by a power m. A power minus m is equal 1 by a power m, where a power m is the multiplicative inverse of a power m. A power minus m, where a power m is the after observe these patterns, we can say generally for any non-zero integer a power minus m is equal to 1 by a power m. A power minus m is equal to 1 by a power m, which is multiplicative inverse of a power m. Why? Because 1 by a power m into a power m is equal, this 1 by a power m is write as a power minus m into a power m that equal to a power minus m plus m that equal to a power 0 that equal to 1. So, this 1 by a power m is the multiplicative inverse of a power m. Okay, after learning this, could you write the multiplicative inverses of given numbers? Okay, try to write the multiplicative inverse of these numbers. 1 3 power minus 5, 4 power minus 3, 7 power minus 4, 7 power minus 3, x power minus n. Okay, like this. I write some problems. Okay, what is the multiplicative inverse of 3 power minus 5? What is the multiplicative inverse of 3 power minus 5? What is the multiplicative inverse of 3 power minus 5? Tell. It is 3 power 5. Okay. What is the multiplicative inverse of 4 power minus 3? 4 power minus 3. The multiplicative inverse of 4 power minus 3 is 4 power 3. What is the multiplicative inverse of 7 power minus 4? The multiplicative inverse of 7 power minus 4 is 7 power 4. What is the multiplicative inverse of 7 power minus 3? The multiplicative inverse of 7 power minus 3 is 7 power 3. 7 power 3. What is the multiplicative inverse of x power minus n? The multiplicative inverse of x power minus n is x power n. X power n. Okay? Do you understand how to write the multiplicative inverse of given numbers? Okay. Now we learn how to express the numbers. How to express the numbers in expanded form by using exponentials. By using exponentials. For example, I take a number 3456. 3456. Okay. First, expand the number. 3 is in thousands place. So, write 3 into 1000 plus 4 is in hundreds place. So, you can write as 4 into 100. 5 is in tens place. Write it as 5 into 10. 6 is in ones place. So, write it as 6 into 1. Okay. We already know in earlier classes how to expand the numbers. But here we are doing another step. That is, here we are using exponentials. Exponentials. Okay. 3 into 100. 3 into 1000. 3 into 1000 here. Here 1000 in 1000. 1 follows 3 zeros. 1 follows 3 zeros. How do you write in exponential form? This 1000 is write as 10 power 3. 3 into 10 power 3 plus 4 into 100. In 100, 1 follow 2 zeros. 1 follow 2 zeros. So, it is write as 10 square plus 5 into 10. Here 10 in 10, 1 follows only 1 zero. This is write as 10 power 1. Here 6 is in 1's place. 6 ones are here. So, how do you write? Can you write in the power of 10th powers? Can you express 1 in the power of tens? In the power of tens, recall. We have a law, that is a power 0 is equal to 1. A power 0 is equal to 1 where a is not equal to 0. Where a is not equal to 0. So, here 1 is also write 10 power 0. 10 power 0. Okay. This is the expanded form of a given number by using exponentials. By using exponentials. Do you understand? Do you all understand? Okay. I will take one more number. I will take one more number. Okay. For example, 1056. 1056. Okay. 1. 1 is in thousands place. 1 is in thousands place. So, we write as 1 into 1000 plus the place value of 0 is 0. Next, 5 is in tens place. So, I write as 5 into 10 plus here also 6. 6 is in ones place. So, 6 ones are 6. Now, in the same manner, 1 into, here we are using exponentials, 1000. Write as, here 1 follow 3 zeros. It is write as 10 power 3 plus 0. 5 into 10. 10 power 1. 10 power 1. Here only 1 10 is there. So, it is write as 10 power 1 plus, we already know the law. Okay. A power 0 is equal to 1. So, here 1 write as 10 power 0. Why? Because the value of 10 power 0 equal to 1. This is the expanded form of given numbers by using exponentials. Okay. Now I take a decimal number. And learn how to write the decimal numbers in expanded form by using exponentials. Okay, students. Now I take a decimal number, that is 734.684. 684. Okay, 734.684. This is the decimal point, this is the decimal part, and this is integer part. Okay, now write the expanded form of this number. Okay, 734. 700. It is write as 7 into 100 plus 3 into 10 plus 4 into 1 plus, how do you write? This is in 10th place. This is in 10th place. 6 is in 10th place. So its place value is 6 by 10. 6 by 10. This 8 is in 100th place. 100th place. So the place value of 8 is 8 by 100. 8 by 100. This is in 1000th place. So the place value of 4 is 4 by 1000. 4 by 1000. Okay, now just first we write the expanded form of given decimal number. Now we write it again by using exponentials. Okay. 7 into, you already know in previous problems. Okay. Here in 100, 1 follow 2 zeros. So this is write as in exponential form 10 power 2 plus 3 into, here 1 follow only 1 zero in 10. So it is write as 3 into 10 power 1 plus, here there are no tens, but we know a power 0 is equal to 1 where a is not equal to 0. So 1 can write as 10 power 0 plus, here 6 by 10, here 1 follow 1 0. So it is write as 10 power 1 plus, in 8 by 100, 1 follow 2 zeros. It is write as 10 square plus, in 4 by 1000, in 1000 1 follow 3 zeros. So it is write as 10 power 3. 10 power 3. Okay. Now 7 into 10 power 2 plus 3 into 10 power 1 plus 4 into 10 power 0 plus, this is right as, I just modified, you already know the law. A power minus m is equal, a power minus m is equal 1 by a power m, or a power 1 by a power minus n is equal a power n. Okay, this is also right as 10 power minus 1. 10 power minus 1. 6 into 10 power minus 1 plus, this is right as 8 into 10 power minus 2 plus 4 by 10 power 3, right as 4 into 10 power minus 3. 4 into 10 power minus 3. Okay, in this way we can write the decimal numbers in expanded form by using exponential. Okay, you understand? Now we are going to learn the second concept, laws of exponents. We already learned laws of exponent in 7th class. In 7th class with the positive exponents. Now in this class the same laws are applicable for the negative integers or not. We are taking some examples. Here I consider a number. Here I consider a number. That is 3 power 2 into 3 power minus 4. 3 power 2 into 3 power minus 4. Okay. We know the law. A power m into a power n is equal to a power m plus n. A power m plus 1. Okay. Now here also same basis and exponents are different. Exponents are different. So we connect to this formula. Okay. The resulting answer is, we write the same base. And powers are added. When they are in product, the powers are added. So here also I write the same base. At the same base. Next, add the exponents. 3 power 2 plus of minus 4. 2 plus of minus 4. That equal to 3 power 2 plus into minus. Minus 2 minus 4. 2 minus 4. That equal to 3 power minus 2. 3 power minus 2. 2 minus 4 equal to minus 2. Now, this is also write as 1 by 3 power 2. 1 by 3 power 2. What is the reason? A power minus m is equal to 1 by a power n. 1 by a power n. Okay. That means the laws which are learned in 7th class for positive powers, here we may also use for negative exponents. Okay. I take one more example. Minus 2 whole power minus 3 into minus 2 whole power minus 4. Minus 2 whole power minus 4. Minus 2 whole power minus 3 into minus 2 whole power minus 4. When you observe, the bases are same. Okay. Exponents are different. By using the same law, a power m into a power n is equal to a power n plus n. A power m plus n. Now we get, write the same base. What is the base here? Minus 2 and add the exponents. Minus 3 plus of minus 4. Then we get minus 2 whole power minus 3 plus into minus minus 4. That equal to minus 2 whole power minus 3 minus 4. That is equal to minus 7. That equal to, this is also write as minus 2 whole power minus 7. Write as 1 by minus 2 whole power 7. Minus 2 whole power 7. Okay. Here we use two laws. What are they? A power m into a power n is equal to a power m plus n. That is product law. This is negative exponent law. Okay. A power minus m is equal to 1 by a power m. 1 by a power n. In general, we could infer that for any non-zero integer a power m into a power n is equal to a power m plus n, where m and n are integers. Okay. Similarly, we can verify the other laws of exponents also. For any non-zero integers a and b, and m comma n are integers, a power m into a power n is equal to a power m plus n A power minus m is equal to 1 by a power m. This is negative exponent law. Here, for the same basis and different exponents, quotient law, a power m by a power n is equal to a power m minus n, where m greater than n. The fourth one is power to the power law, that is a power m whole power n is equal to a power mn. A power m into b power m is equal to ab whole to the power m. Here exponents are same, bases are different. And the sixth is a power m by b power m is equal to a by b whole power m. A by b whole power m. The seventh one is zero exponent law. That is a power 0 is equal to 1 where a is not equal to 1. Where a is not equal to 1. Okay. Now, can you find any relation between, m and n? M and n in if a power m is equal to a power n. A power m is equal to a power n. Okay. Then given a power m is equal to a power n. Okay. I transpose a power n this side, left side. Then we take a power m by a power n is equal to 1. Why? Because we transpose a power n to the left side. Okay. Now, a power, here by using this quotient law, a power m by a power n is equal to 1. A power m by a power n, write as a power m minus 1. We also know 0 exponent law, 1 is equal to a power 0. For any base to the power 0, we get 1. So, here 1 write as a power 0. Why? Because in the left side the base is a. So, I take here base as a. Okay. Now, what do you get? Now, what do you get? M minus n is equal to 0. M minus n is equal to 0. That equal to m is equal to n. M is equal to n. Okay. That means if a power m is equal, if a power m is equal a power n, then m is equal to n. M is equal to n. If bases are equal, then exponents are also equal. We can say if bases are equal, then exponents are also equal. Okay. In 8th class, he want to simplify the given problems. And sometimes he also asks simplify and give regions. Simplify and give regions for the problems, for the given problems. Okay. For example, I take some problems. Okay. Now we solve the problems in exercise 4.1. Exercise 4.1. In the first problem, simplify and give regions. Simplify and give regions for the following problems. What are the following problems are? First one is 4 power minus 3. The second one is minus 2 whole power 7. Simplify and give regions. the second one is minus 2 whole power 7. And the third one is 3 by 4 whole power minus 3. And the fourth one is minus 3 whole power minus 4. Minus 3 whole power minus 4. For the first one, here for the first one is 4 power minus 3. This is negative exponent law. Negative exponent law. We know a power minus m is equal 1 by a power m. 1 by a power m. So, it is write as 1 by 4 power 3. 1 by 4 power 3. 1 by 4 power 3 means 4 multiply itself 3 times. Okay, that is write as 4 into 4 into 4. That equal to 1 by 4 4 is 16. 16 4 is 64. 16 4 is 64. Okay, I explain the third problem. I explain the third one. 3 by 4 whole to the power of minus 3. 3 by 4 whole to the power of minus 3. We know a by b whole power m is equal a power m by b power m. A power m by b power m. Okay. Here also by using this formula or by using this law, we can write this 3 power minus 3 by 4 power minus 3. 3 power minus 3 by 4 power minus 3. Now, what law we use here? Negative exponent law. What is the law? A power minus m is equal 1 by a power m. 1 by a power m. So, we can write 4 power 3 by 3 power 3. 3 power minus 3 is equal 1 by 3 power 3. 1 by 4 power minus 3 is equal 4 power 3. Now, write the expand form of these numbers. 4 power 3, write as 4 into 4 into 4 by 3 power 3, write as 3 into 3 into 3. Now, the value of 4 into 4 into 4 is 64. The value of 3 into 3 into 3 is 3 3s are 9, 9 3s are 27. 9 3s are 27. So, 3 by 4 whole power minus 3 is equal 64 by 27. 64 by 27. In this first problem, I explained two problems. Okay? Other two problems solve yourself. Try to solve yourself. Okay? Go to second problem. Go to second problem. Here, in the second problem, simplify the following. Simplify the following. Here, in total, there are 5 problems. I explained 2 problems for you. Other 3 problems, you solve yourself. Okay. Explain the second one. In second problem, minus 2 whole power 7 into minus 2 whole power 3 into minus 2 whole power 4. Minus 2 whole power 4. Observe the problem. What do you observe? Here, base is minus 2. Here also base is minus 2. Here also base is minus 2. Okay? Here bases are same with different exponents. With different exponents. So, what law you use here to solve this problem? A power m into a power n is equal a power m plus. By using this law, we can solve this problem. We can simplify this problem. Okay? Write the same base. Write the same base and add the exponents. And add the exponents. Okay? What are the exponents here? 7 plus 3 power 7 plus 3 10, 10 plus 4 14, minus 2 whole power 14. Okay. This is the simplest form of given problem. Okay. Next, I want to explain one more problem. In the second one, I take the fourth one, 5 power minus 4 by 5 power minus 6 whole to the power into 5 power 3 into 5 power 3. 5 power minus 4 by 5 power minus 6 into 5 power 3. This is the given problem. How do you solve? Which law you use? Which law you use to solve this problem? Here we are observing negative exponents. Negative exponents. Okay. This is also write as by using negative exponent law, a power minus m is equal 1 by a power m and 1 by a power minus m is equal a power n. A power n. We can write this 5 power 6. 1 by 5 power minus 6 is equal 5 power 6. 5 power minus 4 is equal 1 by 5 power 4. 1 by 5 power 4. Okay. Into 5 power 3. Into 5 power 3. Now, if you observe these two, both are in product and bases are same with different exponents. We use the first law. We can use the first law, which is a power m into a power m is equal a power m plus n. That equal to 5 power. Write the same base. That is 5. Now we add the exponents. 5 power 6 plus 3. 6 plus 3 by 5 power 4. By 5 power 4. Now we get 5 power 9 by. Now we get 5 power 9 by 5 power 4. 5 power 9 by 5 power 4. Okay. What do you observe here? Here also same basis, but with different exponents, but in by form, division form. Then what formula you use? A power m by a power n is equal a power m by a power n is equal a power m minus n, where m greater than n. Where m greater than n. Now write the same base. Write the same base and subtract the exponents. And subtract the exponents. 9 minus 4. 9 minus 4. Here m is greater than n. That's why 9 minus 4. That equal to 5 power 5. That equal to 5 power 5. Okay. The simplest form of 5 power minus 4 by 5 power minus 6 into 5 power 3 is 5 power 5. 5 power 5. Okay. Go to third problem. In the second one, I also solved 2 problems. Next 3 problems you solve yourself. Okay, I go to next problem. Simplify. In third problem, first one, 2 square into 3 square by 2 power minus 2 into 3 power minus 1 into 3 power minus 1. Okay. Here also simplify. Okay. Now 2 power 2. This is in denominator. 2 power minus 2 is denominator. I write this 2 power minus 2 by 2 power 2 by 2 power minus 2. 2 power 2 by 2 power minus 2 into as one group into powers of 3 write as one group. Okay, 3 power 2 into 3 power minus 1. 3 power 2 into 3 power minus 1. Okay. Now, observe this. 2 power 2 by 2 power minus 2. What do you observe? Their bases are same. No, different, same exponents, but here bases are same. Bases are same. We use 2 laws here. We use 2 laws here. Okay. We can use third law and sixth law also. Third law or sixth law also. Okay. Now, I use to solve the first problem in third one. 2 power 2 into 3 power 2 by 2 power minus 2 into 3 power 1. I write the powers of 2 as one group and write the powers of 3 in the second group. Okay. Now, we use the first law to solve this, to simplify this. That is a power m to solve the first problem in third one. First, we group the, I write the one group of powers of 2 and write the powers of 3 as second group. Okay. Here, 2 power 2 by 2 power minus 2. 2 power 2 by 2 power minus 2. Here, exponents are different. Bases are same. Bases are same. So, we use a power m by b power m is equal. So, we use a power m by a power n is equal a power m minus 1. A power m minus n. So, 2 power 2 minus, you have to subtract the exponents. So, 2 minus, or the second exponent is minus 2 into, here we use the first formula, that is a power m into a power n is equal a power m plus n, 3 power 2 plus of minus 1. 2 plus of minus 1. This is write as 2 power 2 into 2 minus of minus, that is equal to plus 2 into 3 power 2 plus of minus, so minus 1, that equal to 2 power 4 into 3 power 1. 2 power 4 into 3 power 1. 2 power 4. What is the value of 2 power 4? That is 16 into 3. That equal 48. That equal 48. Okay. The simplification of given problem is equal to 48. In fourth problem, simplify and give regions. Simplify and give regions. Simplify and give regions. Okay. The first problem is 4 power 0 plus 5 power minus 1 into 5 power 2 into 1 by 3 into 1 by 3. Okay. Now, how do you solve this problem? We know 4 power 0. What is the value of 4 power 0? a power 0 is equal to 1. You recall the law? 0 exponent law. Okay. The value of 4 power 0 is 1. Write the region also. You want to give regions also. So we must write the regions. Okay. A power 0 is equal to 1, where a is not equal to 0. Then what is the value of 5 power minus 1? The value of 5 power minus 1 is equal to 1 by 5 power 1. Okay. Into 5 square into 1 by 3, that equal to, this is 1 plus 1 by 5 power 1 means 5. 1 plus 1 by 5 equal to 5 1 is 5, 5 plus 1, 6 by 5. You can write it as 1 plus 1 by 5 equal to 6 by 5 into 5 square into 1 by 3. Okay. Otherwise, write it also 5 square equal to 25. 5 square equal to 25. Cancel 25 and 5 by 5. 5 1 are 5. 5 5 are 25. By 3 table. 3 1 are 3. 3 2 are 6. What is remain? 5 2 are 10. 5 2 are 10. Okay. Here we use two formulas, that are a power 0 is equal to 1, where a is not equal to 0, and a power minus n is equal 1 by a power n. 1 by a power n. Okay. Next, I explain the third problem. Okay. The third problem is 2 power minus 1 plus, I explain which are some different. The other problems solve yourself. 2 power minus 1 plus 3 power minus 1 plus 4 power minus 1 into 3 by 4. Into 3 by 4. These numbers having negative exponents. Here we use negative exponent law. Negative exponent law, that is a power minus n is equal 1 by a power m. 1 by a power m. Now this is equal to 2 power minus 1 is equal to 1 by 2 power 1. That means 2 power 1 is equal to 2. 3 power minus 1 is equal to 1 by 3 power 1, that is equal to 3. 4 power minus 1 is equal to 1 by 4 power 1. 4 power 1 is equal to 4 into 3 by 4. Here we use what law? A power minus m is equal 1 by a power m. 1 by a power m. Now we have to add these three numbers. Here 1 by 2 plus 1 by 3 plus 1 by 4. When you observe these three numbers, these are unlike fractions, different denominators. Then how do you add? First, we find out the LCM of denominators. 2, 3, 4. 2 1 are 3 carry, 2 2s are. Now these are 4 primes. So we get the LCM 2 into 3 into 2, that equal to 12. That equal to 12. Okay. Write the LCM as denominator. Now 1. Write the numerator and denominator. See the denominator. The denominator goes how many times in the LCM? Or here denominator. Okay. 2 goes in 12 6 times. So write the next numerator. The next numerator is 1 and the denominator, next denominator is 3. 3 how many times divides 12? 4 times. So 4 plus, write the third denominator, third numerator, 1 into, now what is the third denominator? 4. This 4 how many times goes in 12? 3 times. Into 3 by 4. Into 3 by 4. Okay. That equal to 6 1 are 6 plus 4 1 are 4 plus 3 1 are 3 by 12 into 3 by 4. 6 plus 10. 6 plus 4 10. 14. 13 by 12 into 3 by 4. Here 3 1 jar, 3 4 jar. Now 13 1 jar 13, 4 4 jar 16. After simplification we got 13 by 16. 13 by 16. Okay. I will explain one more problem. In fourth one, that is 3 by 2 whole power minus 2 whole power 2. Power to power. Power to power. Now, we use a power m whole power n. Power to power law. A power m whole power n is equal a power mn. A power mn. Okay. Now, this is right as 3 power 2 multiply the powers. Multiply the powers. 2 2 are 4. Here minus 2 into 2 that equals minus 4. Now it is right as by using this law a by b whole power m is equal, this exponent belongs to numerator and denominator. A power m by b power m. Okay. Now it is right as by using this law 3 power minus 4 by 2 power minus 4. By using negative exponent law, a power minus m is equal 1 by a power m. Now it is right as 3 power minus 4 equal to 1 by 3 power 4 and 1 by 2 power minus 4 is equal to 2 power 4. So it is right as 2 power 4 by 3 power 4. Now what is the value of 2 power 4? That equal to 16. That equal to 16. What is the value of 3 power 4? 3 power 4 is equal 3 into 3 into 3 into 3. That equal to 81. Now we get 16 by 81. This is the simplest form of this problem. 3 by 2 whole power minus 2 power 2. Okay. Here we use the power to power. Power to power. A power m whole power m n is equal to a power mn. Okay. Then we get 3 by 2 whole power minus 2 into 2 minus 4. Minus 4. After we use this law. Okay. A by b whole power m is equal to a power m by b power m. Okay. Then we get 3 power minus 4 by 2 power minus 4. For different bases with same exponent, the same exponent belongs to the numerator and denominator also. So, to write this 3 power minus 4 by 2 power minus 4. Okay. Now, by using a power minus m is equal to 1 by a power m, negative exponent law, we write this 2 power 4 by 3 power 4. The value of 2 power 4 is 16 and the value of 3 power 4 is 81. Okay. Go to next problem. In this exercise, all problems are simplify and give regions like these problems. Okay? By using the laws, we can simplify the given problems easily. In fifth problem, I explain the first one for you, to you. That is 3 square minus 2 square divided by 1 by 5 whole square. 1 by 5 whole square. Okay. First, we solve with the small brackets. First, we simplify the numbers which are in small brackets. First, what is the value of 3 square? 3 into 3. That is equal to 9 minus, what is the value of 2 square? 2 square. 2 into 2. That is 4 divided by 1 by 5 whole square. Now we subtract 4 from 9. We get 5. 5 divided by 1 by 5 whole square. Okay. Now, how do you multiply? How do you divide? 5 divided by 1 by 5. Write the first one. You multiply the first number by the reciprocal of second number. Now we get 5 into 1 by 5. What is its reciprocal? 1 by 5 reciprocal? 5. 1 by 5 reciprocal is 5. 5 into 5, 25. 25 whole square. The square of 25. That equal to 625. 625. Again, the given problem is 3 power minus 2 minus 2 power 2 divided by 1 by 5 whole square. Divided by 1 by 5 whole square. Okay. The value of 3 square is 9. And the value of 2 square is 4. Divided by 1 by 5. You don't change any change in the second term. Okay. 9 minus 4, we get 5 divided by 1 by 5 whole square. 5. When divide two numbers, the first number write it as it is. The first number is multiplied the reciprocal of second number in division. Okay. So here 1 by 5, the reciprocal of 1 by 5 is 5. So 5 into 5. 5 5 is 25. 25 square is equal to 625. 25 square is equal to 625. Okay. In fifth problem, there are 2 sub-problems. I solved one for you. Okay. You try to solve the second problem in fifth one. Okay. Now, I explain the problems in sixth problem. First one. Okay. Here, in sixth problem, you want to find the value of n in each of the following. The first one is 2 by 3 whole power 3 into 2 by 3 whole power 5 is equal to 2 by 3 whole power n minus 2 whole power n minus 2. Okay, this is the given problem. In the heading, find the value of n. Find the value of n. Here, we have to find the value of n. Okay, how could you solve? How could you find? Okay, observe the given problem. 2 by 3 given 2 by 3 whole cube into 2 by 3 whole power 5 is equal to 2 by 3 the power of 9 by 2. Okay, this is. When you observe the given problem, here the base is 2 by 3. Here also the base is 2 by 3 with different exponents. Then we can use the first law, that is a power m into a power n is equal to a power m plus n. To simplify this, we use the first law, that is a power m into a power n is equal to a power m plus n. Then here write the same base and add the exponents. 3 plus 5 is equal 2 by 3 whole power n minus 2. Now again, here is equal between these two exponential numbers. Okay, when you observe again one more time, here also base is 2 by 3, here also base is 2 by 3. Okay, we already learned the relation. What is the relation? If a power m is equal to a power n, then m is equal to n. M is equal n. If bases are equal, then exponents are also equal. Here bases are equal. So exponents. What is the exponent here? 3 plus 5. That is equal to 8 is equal. What is the exponent here? N minus 2. These two are also equal. Why? Because here bases are equal. So now I write this RHS as LHS. This LHS write as RHS. Okay. Now simplify the equation. Simplify the equation. Now I transpose minus 2 that side right side. Now I get here minus 2. When I transpose minus 2 to the right side, it becomes plus 2. Now n is equal 8 plus 2. That is equal to 10. So what is the value of n? What is the value of n here? 10. We solve this problem. Okay. By using the law, by using two laws. What are the two laws? A power m into a power n is equal to a power m plus n. A power m plus n. And we also use the second law. We also use another law. A power m is equal to a power n is n. Then m is equal n. M is equal n. By using these two laws, we solve the problem. We find out the value of n. Find out the value of n. In the same model, we solve the other two problems in this problem. In sixth problem, there are two more problems. We try to solve reversal. Seventh problem. Find x. Find x. If 2 power minus 3 is equal 1 by 2 power x. 1 by 2 power x. How could you solve the problem? Now, in solution, first you write the given one. What is given? 2 power minus 3 is equal 1 by 2 power x. 1 by 2 power x. Okay. This is in numerator and this 2 power x is in denominator. So, we send them in the numerator. Okay. 1 by 2 power x. Write as 2 power minus x. 1 by x power n is equal x power minus n. X power minus n by using this law. Okay. When you observe this, 2 power minus 3 equal to 2 power minus x. Here base is 2. Here also base is 2. Okay. Here bases are equal. Then exponents are also equal. Why? Because if a power m is equal to a power m, then m is equal to n. If bases are equal, then exponents are also equal. Now, what are the exponents here? Here, the exponent is minus 3. Here, minus x. Okay, both sides minuses are cancelled. Then we get, therefore, x is equal 3. X is equal 3. Okay, in this way, we find the missing values. We find the values of variables. Find the values of variables. Okay, 8 problems also. You solve the 8 problems easily. Now, I explain the one more problem in 9th one. One more problem in 9th one. Okay. different to the before problems. So I explain it. If m is equal to 3 and n is equal to 2, find the value of 1. 9m square minus 10n cube. 9m square minus 10n cube. Here also 4 problems are given. The problems are given. I explain 2 problems for you. Do you? For other 2 problems, you solve yourself. Okay? I explain the first problem and the third problem. The third problem is 2m cube plus 3n squared minus 5m squared n. 5m squared n. To solve the first problem in 9th one, given, first you write the given one. Given m is equal to 3 and n is equal to 2. Given expression is 9m square minus 10n cube. You substitute the values of m and n in the given expression. Okay? 9. What is the value of m? You have given the value of m is 3. So I substitute. I replace m by 3. 9 into m square. 9 into 3 square minus 10n cube. That means 10 into n cube. 10 into, I replace 2 in the place of n. 2 cube. Now 9 into 3 square. That means 3 into 3. 9 minus 10 into 2 cube. 2 into 2 into 2. That means 8. The value of 2 cube is 8. Now 9 9 jar 81 minus 10 8 jar 80. Okay. Subtract 80 from 81. Now you get 1. Therefore, when you substitute the values m is equal to 3 and n is equal to in the given expression, we get 9m square minus 10n cube is equal to 1. Okay. Now, in third problem, here also given m is equal to 3 and n is equal to 2 and n is equal to 2. Given expression is 2m cube plus 3m square minus 5m square n. 5m square n. That equal to 2 into 2m cube means 2 into m cube. That means 2 into, you substitute, I replace m is equal to 3 in m cube. Okay. M cube, that means 3 cube. 3 into n is equal to 2 here. So n square, that means 2 square minus 5m square n means 5 into m square into n. Then 5 into m square. The value of m is given 3. 3 square into n. The value of m is 2. Okay. Students, 2 into 3 cube. 3 cube means 3 into 3. That equal to 27 plus 3 into 2 square 4 minus 5 into 9 into 2. 27 2s are 54 plus 3 4s are 12 minus 5 9s are 45 are 90 or 5 2s are 10, 10 9s are 90. Now add these two terms. 66, we get 54 plus 12 is equal 66 minus 90. 66 minus 90, we get 23. We get 23. Okay? You understand, students? I take one or two problems in each Roman in exercise 4.1. You try to solve the other problems yourself. Okay? Now we are going to learn the third concept, which is application of exponents to express numbers in standard form. Application of exponents to express numbers in standard form. What is standard form of a number? If a number is expressed as the product of an integer and powers of 10, where the integer is from 1 to 9 and the n is an integer. The standard form of a number is in the form of a into 10 power n. The value of a is from 1 to 9, and n is an integer. Already we learned the very large numbers. Okay. For example, I take here 300 million. Here 3 follows 8 zeros. Okay. We can write this number 3 into 10 power 8. 3 into 10 power 8. Is it in standard form or not? Observe. Yes, it is in standard form. Why? Because this is an integer which is from 1 to 9 and this is powers of 10. Okay. So this is in standard form. Okay. Now if you observe the second one, diameter of a wiring computer chip is 0.000003. 0.000003. Okay. You write this number in standard form. How to write a decimal number, a very small number, in standard form? First, you write the decimal number in P by Q form. How do you write? You write the number without zeros as numerator 3 by. You count the places. In decimal part 1, 2, 3, 4, 5, 6. So you write the denominator as 1 follows. Here 6 places in decimal part. So 6 zeros. Now 3 by. It is written in exponential form. Here 1 follows 6 zeros. So it is written as 3 by 10 power 6. Now it is called 3 into 10 power minus 6. 3 into 10 power minus 6. Now it is in standard form. A into 10 power n. An integer which is from 1 to 9 into powers of 10. I will explain one more problem. Okay. The size of plant cell which is 0.00001275 meter. 1275 meter. Okay. Now 0.00001275 meter. This is also a decimal number, very small number. Okay. Now you write this number, that is 1275. Okay. Count the number of places in decimal part 1, 2, 3, 4, 5, 6, 7, 8. So you write the denominator. 1 follows 8 zeros. 7, 8. Now it is write as 1275 by, here 1 follows 8 zeros. So 10 power 8. The denominator 10 power 8. This is write as 1 by 10 power 8. Write as 10 power minus 8. Now is it in standard form? No. Why? Because here the integer must be from 1 to 9. But this is 1275. So if you change the number as 1.275, we get an integer which is from 1 to 9. Okay. To change this number, after 3 digits, we need a point. Okay. So, to get it, 1.275. Okay. How do you get? If you divide this number by 1000, we get 1.275. Okay. 2. Don't change the value of this. We multiply again by 1000. Now this is right as 1.275 into 10 power 3 into 10 power minus h. Now 1.275 into, by using loss of exponents, 10 power 3 into 10 power minus 8, we get 10 power minus 5. We get 10 power minus 5. Okay, there is a shortcut also. If this one is given as a up mark bit, then you use the shortcut. Okay, we need a point after 1. We need a point after 1. How many places the point has to move? 1, 2, 3, 4, 5 places. 1, 2, 3, 4, 5 places. So, you write it 1.275 into the point moves right side. So, here we get negative exponents. This is your final answer. Both are equal. This is shortcut. How do you write? Write down the decimal point moves to 5 places right. So, you write the 5 as a power of 10 with negative power, with the negative sign. Negative sign. Okay. Now, I explain some more problems in 4.2. Before going to 4.2, we also learn the concept 4.4, comparing very large and very small numbers. Comparing very large and very small numbers. Here the diameter of the sun is 140 crore meters and the earth is 127540 meters. If you want to know how bigger the sun than the earth, okay, to compare, we have to compare the diameter of the sun to the earth. Okay, here given the diameter of the sun is 140 crore meter and the diameter of the earth is 12,750 million meter. 12,750 million meter. Okay. Write in exponential form. 14 into 1, 2, 3, 4, 5, 6, 7, 8 zeros. 14 into 10 power 8. This is right as 1275 into 10 power 4. 10 power 4. This is also right as I already told a shortcut. Here we need a point to convert it in standard form. We need a point after 1. So here this number has not have any point. That means the point has after last digit. So the point this is write as 10 power, the point moves three places to the left side. So left side moves, so we get a positive power. Here 10 power 4 into 10 power 4. Now it is equal to 1.275 into 10 power 7. 1.275 into 10 power 7. Okay. Now to compare, I divide the both diameters. Diameter of sun. I divide the diameter of sun by diameter of earth. Okay. 1.275 into 10 power 7. This is write as 14 into 10 power 1 into 10 power 7. Okay. By 1.275 into 10 power 7. We cancelled 10 power 7, 10 power 7. Okay. Now we have 14 into 10 power 1 by 1.275. 1.275 means 1 point something. 1 point something. Okay. This is approximately equal to 100. It is approximately equal to 100. Okay. That means the diameter of sun is 100 times to the diameter of earth. Diameter of earth. Now we'll solve some problems in exercise 4.2. Okay. In fourth concept, we learn how to compare very large numbers and very small numbers. How to compare very large numbers and very small numbers. Okay. The diameter of the sun is 14 billion meters. 14 billion meters. And the diameter of the earth is 12 billion 750 million meters. The diameter of the sun is 14 billion meters. 14 billion meters. Okay. Now in the fourth concept, we are going to learn how to compare very large and very small numbers. Very large and very small numbers. For example, the diameter of the sun is 140 crore meters. The diameter of the sun is 140 crore meters. And the diameter of the earth is 12 million 750 million meters. 12 million 750,000 meters. 750,000 meters. Okay. Now I write this number 140 crore as here 14 follows 8 zeros. 14 follow 8 zeros. 14 into 10 power 8. 14 into 10 power 8. Now this is not in standard form. Now I change this number in standard form. To change this number into standard form, after 1, between 1 and 4, we need a decimal point. We need a decimal point. So the point moves to left side. The point moves to left side. So it is multiplied by powers of 10. One place moves it left. So we get a positive power. Positive power. It moves one place. So it is multiplied by powers of 10, which is 10 power 1. Which is 10 power 1. Now we write it as 1.4 into 10 power 1 into 10 power 8. Now 1.4 into 10 power 9. We add the powers 1 plus n, that equal to 9. The diameter of the earth is 12,750,000 meters. 750,000 meters. This is right in exponential form 1275 into 10 power 4. Here it follows 4 zeros. Okay, it is right as 10 power 4. It is also not in standard form. It is also not in standard form. To convert this into standard form, we need a point after 1. After 1, because in the standard form, the integer has 1 to 9 digits. 1 to 9 digits. Okay. So, it moves, the point moves 3 places to the left. So, we multiply 1.275 into 10 power 3 into 10 power 4. Okay. Now we get 1.275 into 10 power 7 into 10 power 7. To compare these two diameters, I divide the diameter of sun by 8. I divide the diameter of sun by 8. Okay, 14 into 10 power 9 by 1.4 into 10 power 9 by 1.275 into 10 power 7. Okay, 10 power 9 write as 10 power 2 into 10 power 7. Then this 10 power 7 and 10 power 7 are cancelled. Now we get 1.4 into 10 power 2 by 1.275 by 1.275. Okay, here 1.4, if you take 1.2, the value of the decimal point always less than 1, we get 1. Here 10 square, that means 100. It is, the value of this is approximately equal to 100. That means the diameter of the sun is 100 times more than the diameter of the earth. In this way, we can compare very large and very small numbers. Very large and very small numbers. Okay, do you understand how to compare very large and very small numbers? Now, we solve some problems in exercise 4.2. In exercise 4.2, the first problem is express the following numbers in standard form. Express the following numbers in standard form. Okay, I explained two type of numbers. One is decimal number and one is normal number. Okay, first how to convert the decimal number into standard form. Here given number is 0.000000947. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, 947. Okay, this is the decimal number. How to express it in standard form? To write it in standard form, first you write the P by Q form of decimal number. P by Q form of decimal number. To write a decimal number in P by Q form, you write the just number without decimal. After you count the number of places in decimal part, there are 12 places in decimal part. So you write the denominator as 1 follow 12 zeros. 1 follow 12 zeros. Why? Because here in the decimal part have 12 places. That's why here 1 follow 12 zeros. 6, 7, 8, 9, 10, 11, 12. 12 zeros. Okay. Now it is right as here 1 follow 12 zeros. That's why it is right as 10 power 12. 10 power 12. Now 1 by 10 power 12 right as 10 power minus 12. Now we get 947 into 10 power minus 12. 10 power minus 12. Okay. Now here is it in standard form? No. Is it in standard form? Here you get 947 into 10 power minus 12. Here 947. Okay, so it is not in standard form. The standard form of a number is a into 10 power n, where a is from 1 to 9. From 1 to 9 and n is an integer. N is an integer. Okay, so here the point, we need a point between 9 and 4. After 9. After 9. That means the point moves 2 places to the left. 2 places to the left. So write 9.47. It moves left side. So write a positive 5. 2 places it moves. The power depends upon how many places the point moves. If it moves left, write the positive power. Okay, 2 places it moves. So I write power 2. If it moves 3 places, we write the power 3. If it moves 5 places, we write the power as 5. If it moves left side, we get a positive power. If it moves right side, then you write negative power. Okay, quite opposite. Okay, into 10 power minus 1, that equal to 9.47 into 10 power 2 minus 1. Okay, 9.47 into 10 power minus 10. 10 power minus 10. Okay, I told shortcut to you. I again told you. I can explain now how to shortcut. What is the shortcut for this? Okay, we need a point after 9. We need a point after 9. Here the point moves right side. Here the point moves right side. How many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. 9, 10 places. So it is equal to 9.47 into 10 power minus 10. 10 power minus 10. This is the shortcut. You use this to fill up the blanks. To fill up the blanks. Okay. Now, in second problem, 543 follows 9 zeros. Follows 9 zeros. Okay. To write in a standard form, it is very easy than decimal number. Here 543 follow 9 zeros. Write it as 543 into 10 power 9. 543 into 10 power 9. Now, where is the point? There is no point. There is no point. So that means the point at the end. The point at the end of the number. Okay. Now the point has to move 2 places. 2 places left side. 2 places left side. So write this 5.43. It moves. The point moves 2 places left. So we have a positive power. 2 places moves. That's why I write 2. Okay, positive sign. Okay, into 10 power 9. That equal to 5.43 into 10 power 2 plus 9. We add the powers 2 plus 9, that equal to 11. Okay, this is the standard form of given number. This is the standard form of given number. Okay, do you understand? Now you go to second problem in exercise 4.2. Express the following numbers in usual form. Express the following numbers in usual form. In first problem, in the first one is 4.37 into 10 power 5. 10 power 5. That means to write this 4.37 into 1000000. Okay, 10 power 5. That means lakh. Okay. You know the multiplication of decimals by powers of 10. When you multiply a decimal number by powers of 10, the point moves right side. The point moves right side. How many places the point moves? That depends upon the number of zeros. That depends upon the number of zeros. Here, how many zeros are there? 1, 2, 3, 4, 5. Okay. The point moves right side 5 places. 3, the point moves right side. Why? Because we are multiplying the decimal number by powers of 10. So 1, 2, 3, 4, 5. After the decimal points, if there are any zeros, no value. So that is equal to 4,37,000. 4,37,000. This is the usual form of given number. This is the usual form of given number. Now let's go to second problem. 5.8 into 10 power 7. 5.8 into 10 power 7. That means 5.8 into 10 power 7. Write as 1 power 7 zeros. Here, after multiplication, 2, 3, 4, 5, 6, 7 zeros. Okay, where do we put the point? Here, 7 zeros. Otherwise, right, we put a point after one place. Why? Because how many decimal places are there? One after there is a decimal place. So, we can put a decimal point after one place. Okay, there is no value. That's why this is the answer. Okay, now go to third one. Go to third one. Now 32.5 into 10 power minus 4. 10 power minus 4. 5 into 10 power minus 4. Write as 1 by 10 power 4. 1 by 10 power 4. This is write as 32.5 into 1. 32.5 by 1, 2, 3, 4. 10 power 4 write as 10,000. 10 power 4 write as 10,000. Okay. Now, here a decimal number divided by powers of 10. The decimal number divided by powers of 10. When a decimal number multiplied by powers of 10, the point moves right side. Right side. How many places the point moves depends upon number of zeros. Okay. Here a decimal number divided by powers of 10. Then the point moves left side. The point moves left side. Here also the point how many places moves depends on how many zeros are there after 1. Okay. Now here are 4 zeros. So the point moves 4 places left. Okay. Write the numerator. Here point is here. The point between 2 and 5. Here we need 4 places to left. But there are only 2 places. Okay, we need 2 more places. So we keep 2 zeros. After we put a point. After we put a point. So the resulting answer is 0.00325. 0.00325. Okay. Here 3.71529 into 10 power 7 into 10 power 7. Here also 3.71529 10 power 7. Write as 1 power 7 zeros. Here a decimal number multiplied by powers of 10. The point moves to right side. The point moves to right side. How many places? It depends upon zeros, number of zeros. 1, 2, 3, 4, 5, 6, 7 zeros. So the point moves 7 places from where it is. Here the point is now. We need 7 places. Here multiplying, we are doing multiplying. So it moves right side. So we need 7 places to the right. 1, 2, 3, 4, 5. But here only 5 places. So we need 2 more places. I keep 2 zeros. After I put a point, decimal point. Okay. It is the resulting answer to this. Okay. Do you understand how to express the given numbers in usual form? In usual form. Next go to in this exercise, there is one different problem. I will explain it. Okay. In fifth problem, Rakesh solved some problems of exponents in the following way. Rakesh solved some problems of exponents in the following way. Do you agree with the solutions? Do you agree with the solutions of Rakesh? If not, why? If not, why? justify your argument. You also justify your argument. Okay. Here 5 problems are there. Okay. Rakesh solved also. These problems are solved by Rakesh. Okay. He said x power minus 3 into x power minus 2. X power minus 3 into x power minus 2 is equal to x power minus 6. Is it right? Is it right? X power minus 3 into x power minus 2 is equal. We use the law of product. A power m into a power n is equal a power m plus n. A power m plus 1, m plus n. Here also bases are same, different exponents. So we add write the same base and add the exponents. Minus 3 minus 2 that equal x power minus 5 is the answer. But Rakesh got x power minus 6. So is it right? Are you agree with Rakesh? No. Why? Because he got the wrong answer. He got the wrong answer. Okay. Go to next one. Here x power 3 by x power 2. When we divide x power 2, when we divide x power 3 by x power 2, he got x power 4. Is it right or wrong? Just we calculate the problem. Here x power 3 by x power 2. By using quotient law, a power m by a power n is equal a power m minus n, where m greater than n, where m greater than n. Then we get x power 3 minus 2 that equal x power 1 that equal x. But Rakesh got x power 4. Are you agree with Rakesh? No. Why? Because he did it incorrect. He solved the problem incorrectly. Okay. Go to third. In third problem, x square whole cube is equal to x power 2 cube that is equal to x power 8. In this way, Rakesh solved this problem. Now, we solve this problem again. Here, we can use power to power law. Power to power law. A power m whole power n is equal a power mn. Okay, in this way, then we got power, multiply the both powers. Okay, 2 into 3, 6. We get x power 6. This is the correct one. But Rakesh got x power 8. X power 8. So, this is also incorrect. Okay, now go to fourth one. X power minus 2 is equal to root of x. X power minus 2 is equal to root of x. Now, in this way, Rakesh solved. We check whether it is right or wrong. Okay. X power minus 2 is equal to root x. Here, I write the exponential form of root x. What is the exponential form of root x? That is x power 1 by 2. That is x power and 1 by 2. If bases are equal, then exponents are equal. Minus 2 is equal to 1 by 2. Is it true? Is it true? Are they both equal? No, they are not equal. They are not equal. Here, x power minus 2 is equal to root of x. X power minus 2 is equal to x power 1 by 2. X power 1 by 2. They are not equal. They are not equal. Okay. So, it is also incorrect one. It is also incorrect one. Next, go to last one. Here, 3 into x power minus 1 is equal to 1 by 3x. In this way, Rakesh solved. He got the answer 1 by 3x. Okay, we check whether it is right or wrong. 3 into x power minus 1. 3 into x power minus 1. Write as 1 by x. Why? Because a power minus m is equal to 1 by a power m. 1 by a power 1. A power n. So, it is equal to 3 by x. But Rakesh write 1 by 3 by x. 1 by 3 by x. So, it is also wrong. It is also wrong. What do you write the answer? Do you agree with the solutions? Then you said, are you right? I don't agree with the solutions of Rakesh. If not, why? If they are not, why? Our justifications, these are all justifications. Our justification, why they are incorrect. Why they are incorrect. Okay students, we learn all concepts in exponents and powers in this class. All four concepts we learn. Now powers with negative exponents, first we learn. After loss of exponents with negative integer powers. After exponents, write the expanded form. Expanded form also learn how to write the expanded form in by using exponentials. After we learn the fourth concept, comparison of smaller and larger numbers, and how to write very smaller and larger numbers in standard form and also usual form and also usual forms, and also identify common errors in problems of exponents. Okay, which some sums are explained by me and some are lived by me. Okay, which problems are lived by me, you solve them yourself. Okay, thank you to all.